Hello everyone, my name is Jillian and I am a 9th grader in Mr. Cortez's chemistry class during the 2018-2019 school year at SCIZ Medical Academy. I will be talking about a very important concept in chemistry called the
mole. Whoa! A bull?
Okay, no, not that kind of mole. The mole in chemistry is a scientific unit used for measuring large numbers of various small particles, such as atoms, molecules, grams, etc. But before we learn about the mole, you have to understand what the AMU, or atomic mass unit, is. This is the periodic table, something that all chemistry students need to know how to use. Below each element is a number that represents the atomic mass unit that quantifies mass on an atomic or molecular scale, also known as atomic mass. What is atomic mass? 1 AMU is approximately the mass of one single proton or neutron and is numerically equivalent to 1 gram over mole. So, for example, gold has an atomic mass of 196.967 AMU. So 1 mole of gold has a mass of 196.967 grams. The atomic weight of 1 atom of hydrogen is 1.008 AMU. So that of 2 atoms is 2.016. The atomic weight of 1 atom of oxygen is 15.999. So the molar mass of water is 2.016 plus 15.999, which equals 18.015. Here is an example of a mole. How many moles are in 17.0 grams of bromine, or Br2? To start off your equation, first you look at what is given to you in your question. So in the question you have 17.0 grams of bromine. Once you write down the beginning of your equation, you draw another line, and on the bottom of the line you match up the units so they're diagonal to it. Now that you have your units written out, you see that Br2 has a 2 on the bottom of it, and that is called a subscript. So that means that you have bromine molecule that consists of 2 bromine atoms. You now have to figure out the atomic mass of the 2 bromine atoms because you are trying to determine how many moles are in the molecule of bromine. So you will write Br equals 2 times the atomic mass. To find this number, you go to the periodic table and find that bromine is 79.90. So Br2 is 79.90 times 2, which gives you 159.80 grams per mole. So that is what you put on the bottom of your equation. As I said before, 159.80 grams of Br2 equals 1 mole of Br2. And you can inverse this finding. So this is how you would set up your equation. So you would multiply across the top and divide by the grams to determine the moles, which is 0.106 moles of Br2. So to do this, first you should have learned dimensional analysis, which is what I just explained about the matching of the units and then knowing what to multiply on the top and how to divide on the bottom. Now we will move on to Avogadro's number, which is 6.022 times 10 to the 23rd power, also known as 6022 with 20 zeros. Avogadro's number is a way of measuring the mass of tiny little atoms and molecules in grams. So basically, Avogadro's number is a proportion that relates molar mass on an atomic scale to physical mass on a human scale. Avogadro's number is defined as the number of elementary particles, in other words, molecules, atoms, and compounds, in a mole of a substance. So if we go off the same equation we were just using, but we want to extend it a bit further and want to find out how many molecules are in 17.0 grams of bromine, you would continue the equation by adding another section that has the same unit on the bottom, so that they can cancel out and use Avogadro's number, 6.022 times 10 to the 23rd, with the unit of molecules on top. You then complete the equation. To make these calculations, you should have a scientific calculator by your side to help you with the handy-dandy work. Once you plug in these numbers, the answer should be 6.046 times 10 to the 22nd power molecules. Now, the reason you have molecules at the end of your equation is because that is what you ended with when you were setting it up. So as you see, the last thing on the top is 6.022 times 10 to the 23rd power molecules. So whatever you have on the top is what you're trying to find. So always make sure that the unit on top and the end of your equation is what the question is asking for. So that was an example of mass to molecule. Now we are going to move on to molecular mass. How do we find this? First, let's read the question. What is the mass of 5.0 molecules of sulfur? So as said before, you look for the given information in your question. Here it is, 5.0 molecules of sulfur. Set up the equation like this, 5.0 molecules S over 1. Now continuing the dimensional analysis on the bottom of the next line, you will place molecules S so that they can cancel out. So how many molecules are in 1 mole? Remember Avogadro's number, 6.022 times 10 to the 23rd power, are in 1 mole. Now, since we're looking for mass in grams, you are going to do the same dimensional analysis and put mole S on the bottom of the next line. 1 mole of sulfur has 32.066 grams per mole. This atomic mass was found on the periodic table. Once again, you can invert this statement and place the grams on top, since that is what you're trying to find based on the question. So multiply 5 times 1 times 32.066 and divide by 6.022 times 10 to the 23rd power on your scientific calculator. And your answer should be 2.662 times 10 to the 24th power grams of sulfur. Once there are multiple steps in a problem, it gets pretty tricky, but practicing more and more will help you get the hang of it soon enough. Now, to get on to the fun concept, stoichiometry. Stoichiometry is the part of chemistry that studies amounts of substances that are involved in reactions. It is based on the law of conservation of mass. With this, we should remember that matter cannot be created nor destroyed in a chemical reaction. First, let's talk about why stoichiometry is important and why it's used. Stoichiometry is important because it allows us to predict how much of a reactant is used in a chemical reaction, or how much unwanted product is generated. This is important in medicine because doctors and pharmacists need to know the amount of a toxic material a medication forms after it is prescribed and taken. They need to know that toxic side effects are kept to a minimal amount. This is also used in forensics to determine the amount of toxins present in a human's body when the cause of death is unknown. How do you do stoichiometry step by step? Almost all stoichiometric problems can be solved in just 4 simple steps. First, balance the equation. Second, convert units of a given substance to moles. Third, using the mole ratio, calculate the moles of substance yielded by the reaction. And fourth, convert moles of wanted substance to desired units. Let's read the question. Determine the mass of sodium chloride produced when 1.25 mole of chlorine gas reacts vigorously with excess sodium. So to set up our equation, we have to read the question and see what element it is asking for and what it's saying it reacts with. And a reaction is represented by an arrow. As we look at the problem, we see Na plus Cl2, and the 2 is very important. And for this, we should remember the saying, have no fear of ice-cold beer. Or, the beginning letters stand for hydrogen, nitrogen, fluorine, oxygen, iron, chlorine, and bromine. These are the only 7 elements that can exist as molecules. With these elements, you should remember to always put the subscript of a 2 because there are 2 of them in each. So once we have Na plus Cl2, you put on the other side NaCl because together that is what it makes. Now to balance out the equations, we put 2 Na and 2 NaCl so they can balance. And you should know how to balance equations from earlier lessons in the year of chemistry. Now, we do the same thing as before in the video. You look at your question and you get the number that it tells you in your question. 1.25 moles of chlorine gas, or Cl2. So you put 1.25 mole Cl2 on the top of your bar. Then you create your next bar. And this is where the mole ratio comes into play, if you remember from the previous steps. So in stoichiometry, the question will always have a certain part of the equation that you need to look at. So in this equation, we need to look at NaCl and Cl2. So from there, you look in your equation and you see NaCl has a 2 in front of it. So your ratio on the top will be 2 mole NaCl. And on the bottom, you see that you need mole of Cl2. So you look at your Cl2 and you see it has nothing in front of it. So we should know that there is an imaginary 1 there, and that is what takes place in your equation. So you have 2 mole NaCl over 1 mole Cl2. Now we should always remember that every stoichiometry equation should have a mole ratio somewhere in between. We aren't done with the equation yet. As you can see, we ended off with moles, but we are trying to go from moles to mass. So looking on the periodic table, Na is 22.989 and Cl is 35.453 atomic mass. And we add them together to get a total of 58.44 grams of NaCl. You get your answer from the first part of the equation, 2.5 moles of NaCl. And then you do your dimensional analysis as always. You cancel out your units from the top and the bottom that are diagonal. So you put 1 mole of NaCl is equal to, and as we know, a mole is equal to the AMU, 58.44 grams of NaCl. Now, as we look back at the question, we see it says determine the mass of the sodium chloride. So we see that we got up to the grams at the top of your equation, and we know that that is the ending of our equation when you multiply the 2.5 times 58.44. Solve that part of the equation and you get 146 grams of NaCl. Now you're done, and it may look complicated right now, but once you practice and see more examples, you will get the hang of it. Let's move on to our next example of stoichiometry, mass to mass. So our question says, ammonium nitrate, which is NH4NO3, produces dinitrogen monoxide, N2O, gas, and H2O produced from the decomposition of 25 grams of solid NH4NO3. Now we have a big lengthy problem, but all we need to do is break it up into sections to understand what we're doing. First, you read NH4NO3 produces dinitrogen monoxide. So the word produces is what indicates that you're going to draw the arrow from the NH4NO3. Next, you have your remaining elements, which are N2O plus H2O. Now, as the first step of stoichiometry, you must balance your equation. And I already have it balanced up here for you, but some teachers aren't so nice and they're not going to balance it. So make sure you know how to balance equations to continue on with the stoichiometry. Now, let's talk about stoichiometry mass to mass. Personally, I think this one is the hardest one, so I have broken it up into steps to explain how to do it. So the question reads, ammonium nitrate NH4NO3 produces dinitrogen monoxide N2O gas and H2O when decomposed. What is the mass of H2O produced from the decomposition of 25 grams of NH4NO3? As I have said, you start off with whatever is given to you in your question. So in your question, you have 25.0 grams of NH4NO3. And so that's what you start off with. And then as you go diagonal on the bottom, you put your grams of NH4NO3, and on your calculator you would add N plus 4 of hydrogens, and then you add nitrogen again and 3 oxygens. So whenever you add all of those together, you should get 80.04 grams. And then, as we discussed in the beginning of this, 1 mole is equal to the AMU. So that is the first section of what you should do to find the beginning of your equation. Now, you should do 25 divided by 80.04 to get 0.312 moles of NH4NO3. But that's not the end. We still have more because it is asking for grams, and as you know, we're going mass to mass. So you don't stop at moles, so you have to keep on going. And you should always have a mole ratio, and we don't have it yet. So as we go on to the next step, you see that now we have the mole ratio. But to get there, we get the answer from the beginning, which is the 0.312 moles of NH4NO3, and we plug it into an equation. We put another line next to it, and on the bottom, canceling out as usual, mole NH4NO3. So now for the mole ratio. Since we're looking for NH4NO3 and H2O, we look in our equation and we see that NH4NO3 has no number in front, so we know that that's supposed to be a 1. So 2 moles of H2O, because we put a 2 to balance it, 2 moles of H2O is equal to 1 mole of NH4NO3, as it is in the equation. Once you multiply 0.312 times 2, you should get 0.624 moles of H2O. Now, we are not looking for moles of H2O, we're looking for grams of H2O. So we continue on to another step. And this is our last step. You put 0.624 moles of H2O on the beginning of your equation. Now the line next to it, canceling out, moles of H2O. Then you put on top, you have to find H2O's atomic mass. So you put 2 times the hydrogen amount of AMUs plus oxygen. So your answer should be 18.02 grams of H2O. Now, after figuring that out, we simply do 0.624 times 18.02 to equal 11.2 grams of H2O. And that is the end of the equation because we ended up with grams of H2O just like the question had asked. Now, this doesn't have to be separated. You can put it all in the same row, but for this example, I wanted to separate them so you all could get a good understanding of what we're actually doing and what numbers are going where. On our last example of stoichiometry, we have mass to mole. So our question states, how many moles of magnesium nitride is needed to react with an excess amount of potassium oxide to produce 11.6 grams of magnesium oxide? Again, don't let the wording fool you. It's very easy to comprehend. So first, we have to balance our equation as said and as stressed as before. So to balance it, I already have it balanced again. Mg3N2 plus 3K2O produces 3MgO plus 2K3N. Now in our question, we see that it asks how many moles of magnesium nitride is needed to react, and it also gives us 11.6 grams of magnesium oxide. So we take the 11.6 grams and we put it on the top of our equation, and we make sure to draw a bar next to it. And on the bottom, we're canceling out grams of MgO. So what you need to find is the atomic mass of Mg and O put together. So looking on the periodic table and finding the atomic mass of both, and once you add them together, you get 40.304 grams of MgO over 1 mole, because we know that 1 mole is the AMU. Now, as we know also, we need a mole ratio. So our mole ratio here is 3:1. Since we have MgO on the top over here, we have to put on the bottom MgO. So how many moles does it say it has? 3, because the 3 in the front of MgO is the mole. So you put 1 mole of Mg3N2 over 3 moles of MgO. Mg3N2 represents the magnesium nitride that we are trying to find and that the question is asking for. So we end with the mole of Mg3N2, which the question is asking, so we know that we are done setting it up. Now, the tricky part, solving. Okay, it's not that tricky, but we must know how to put the numbers correctly into our scientific calculator. So we have 11.6 divided by 40.304 times 3. So what I would recommend doing is 40.304 times 3, and then you write that on the bottom line, and then you put 11.6 on top, so you remember the two numbers, and then you divide those, and your answer should be 0.095 moles of Mg3N2. Thank you so much for watching my video, and I hope that I taught you a thing or two in stoichiometry or about our very favorite moles.